Hello everyone, I'm Yuxian Lin. Today I'm going to introduce QLED display. And this is my outline. First, I will start with what is QLED, and the second part is the advantage of QLED. And next, I will introduce industry application, and final is conclusion. To know what is QLED, first, we have to know what is quantum dot. Quantum dots are a type of nanoscale semiconductor material with dimensions smaller than 10 nanometers. And due to the quantum confinement effect, ultra-indifferent band structures, which mean ultra-indifferent QD size, allows QD to emit light of various colors. As the picture showing here, by ultra-indifferent size of QD, you can get a different color emitted by QD. And due to this characteristic, by using specific bandgap of quantum dots and applying light energy to excite electrons to the conduction band, the recombination of electrons and holes will release lights of the desired color. And there are two main applications of quantum dots in display. One involves improving existing LCD technology by incorporating QD films to enhance color in displays. The other application is electron luminescence quantum dots QLED, which is called QDEL, where quantum dots serve as the sole light source. This approach enhances color purity and contributes to a sleek and thin display structure. The difference between QLED with QD film and traditional displays lies in the addition of a QD film within a traditional LCD structure. Using blue light as a backlight source, the QD film absorbs the blue light and emits red and green light. There are two kinds of QD film applied on QLED. The first one is quantum dot enhancement film, which is called QDEF. By adding a layer of quantum dot enhancement film in front of LED backlight source, and subsequently supplying energy to the quantum dots on the film through the LED backlight, the quantum dots can exhibit red and green colors. QDEF is the predominant application in current display industry. And for the second one is quantum dot color converter, which is called QDCC. This technology involves using quantum dot color filter to replace traditional color filters, allowing for color transformation rather than direct filtering. It can be integrated with technologies such as micro LED and OLED. For example, in QD OLED displays, a blue OLED serves as a light source, which can emit blue light. Quantum dot color filters then produce red and green light. This approach helps reduce costs while preserving the high contrast ratio of OLED displays. And for the QDEL is an advanced display technology that combines the feature of QLED and electron luminescence. QDEL does not require backlight, but instead directly utilizes an electric current to stimulate quantum dots for luminescence. Since QDEL directly uses an electric current to stimulate quantum dots, it can generate pure and more saturated colors, providing superior color performance, high contrast ratio. Also, without a need for traditional backlight, QDEL contributes to achieving a thinner display design, offering a sleeker appearance. In recent years, there has been a significant improvement in the research outcomes of QDEL devices. Some teams claim the capability to produce devices with brightness reaching several 100,000 nits and an extended lifespan. The future holds promise for the gradual replacement of QD films, making QDEL displays more advantageous in the display technology landscape. For the next part is the advantage of QLED. Compared to traditional LED and OLED, QLED can achieve higher color purity and broader color gamut. In comparison to traditional LED, Both OLED and QLED can cover over 90% of the color gamut, with QLED achieving a slightly higher level. As you can see in the picture, QLED can cover the widest color gamut. Regarding color contrast, while QLED falls slightly behind OLED, it still presents a good color contrast. And for the brightness, compared to the traditional LED, which can achieve 1000 to 2000 nits, and OLED's 500 to 800 nits, QLED can achieve over 4000 nits. QLED also has the advantage of longer lifespan and lower manufacturing costs compared to OLED. And for the next part is industry application. Currently, the majority of QLED displays in production use QD film application instead of QDEL application. Major companies such as Samsung, LG, BenQ, and others have invested in developing their own QLED display. And this is a product overview posted by Samsung in 2020. By QDEF technology, it can achieve superior audio-visual effects and clear color details.
This Samsung 4K QLED TV delivers a picture with more depth, making your entertainment look more vivid and true to life. You get more detail in every shot, making sure you never miss something that's lurking in the shadows with Quantum HDR. Enhanced contrast and clarity allow you to see more details in the dark scenes and appreciate the beauty of bright and vibrant scenes. You get the optimal audio for everything you watch with immersive adaptive sound that automatically adjusts based on what's on screen. It looks good from any angle with no mess of cables and a slim bezel that doesn't get in the way.
And as mentioned earlier, quantum dot film can also be integrated with existing display technologies. For example, in Samsung's newer models of Neo QLED, the integration of mini LED technology, along with the use of an ultra-thin micro layer on the mini LED backlight module, allows for precise pixel control. Coupled with a quantum dot film, this combination achieves a high color accuracy, higher brightness, and a longer lifespan compared to OLED, showcasing the advantages of this technology. At the same time, it can be observed that the popularity of QLED display is increasing year by year, and its future influence should not be underestimated. According to the industry source by Samsung in 2019, it was estimated to have sold a total of 5.4 million units of QLED TVs in the global market, 896,000 units in the first quarter, 1.09 million units in the second quarter, 1.16 million units in the third quarter, and 2.25 million units in the fourth quarter, which is priced at 77 million won in Korea, is equal to 66,000 USD. In conclusion, QLED is considered a product that could replace OLED technology in the future. And final is my conclusion. QLED displays stand out with superior color performance, high brightness, and potential cost advantages. However, addressing challenges in thickness and material stability is essential for sustained competitiveness in the dynamic display market. Furthermore, QLED technology is still in its early stages, and QDEL displays are currently in the research phase. However, their performance is promising and expected to be mature in the near future. And this is my presentation. Thank you for listening.